Hello, you're welcome to this lesson. In this video, you are going to solve this question I have here on the screen. The question says the figure shows a pulley system used to fit a load. If the cable at A is pulled downward at a speed of 8 meters per second and increases at 2 meters per second squared, find the speed and acceleration of the load at B. So let's look at how you are going to solve this question. So actually, when you are given this question, you will be given only this figure here, which is the figure A, and you will have to draw the figure B yourself. Okay, so after drawing figure B, you have to label it as it has been indicated, and also don't forget to draw your datum. So the datum will be this horizontal line that I have here. Okay, so this will be my datum. Okay, so what's happening is that you're going to start measuring the length SB, SC, and then SA from the datum. Okay, so let's look at what you're going to do. So the first thing to do here is to write an equation, okay, which will be an equation relating SA, SB, and SC. Okay, so let's look at how you're going to do this. So in this case, you see that we have two ropes, which is rope 1 and then rope 2. Okay, so what I'll do is that I'll trace rope 1 so that we write an equation for the first rope. So let's look at how I'm going to do that. So oh, that was bad. So for rope 1, we are going to have up to this point. Okay, so that will be the length of rope 1. Okay, so because the datum, because of the datum, we are going to ignore the part of the rope that is behind the datum, okay, which is this portion here. Okay, you are going to ignore this length here. So let's take note of that. Okay, so now you know length L1, right? So you are going to write an equation for length L1. That will be SB plus plus SC. Okay, that should be equal to L1. Okay, so when we add SB and we add SC, we should get length 1, which is the length of the first row. So this becomes our first equation. So now you have to write an equation for the length of the second row. So let's look at how you're going to do that also. Okay, so for the second row, let me trace that one also. So for that one, we have from here, okay, and then we have this length also. Then we have this length here. So we are not considering this length here because they are always constant, so we can ignore them. So to get the second equation, we are going to have SB, okay, plus um, this part, okay, plus this part. And then to get this part, you will have to subtract SC from SB, okay. That will give us the length of that section. So you are going to have plus SB minus SC. Okay, that's what you are going to have. And then plus the last part of the second row, which will be this length here. And then to get that length also, you have to subtract SC from SA. Okay, so you're going to have plus SC. Okay, subtracting SC from SA, so plus SA minus SC. This should be equal to the second length. This becomes our equation 2. So we have two equations with three variables. Okay, so for this reason, we are going to make SC the subject in equation 1. So we are going to have SC to be equal to L1 minus SB. So you substitute this into equation 2. Okay, but before you do that, let's simplify equation 2. So you're going to have SB plus SB, right, minus SC plus SA minus SC to be equal to L2. That's just equation 2, but I just removed the brackets. Okay, so we're going to have 2SB minus 2SC, okay, plus SA. This should be equal to L2. So this becomes our equation 2 now. So now let's substitute this expression into the new equation 2. So we're going to have 2SB minus 2SC, which is now L1 minus SB, okay, plus SA to be equal to L2. So this is the new equation. So now let's simplify this. So we're going to have 2SB minus 2L1 plus 2SB plus SA equals L2. So now let's group the variables on one side. When you do that, we are going to have SA plus 4SB equals L2 plus 2L1. So this becomes the new equation. So this is the equation we have now. So we are going to use this equation to solve the question. So let's continue. So first of all, to find the velocity, okay, to find the velocity of the pulley B, you have to differentiate this equation that we have here. So when you differentiate this, you're going to have VA plus 4VB equals 0. Okay, and you want to find the velocity of pulley B, so you have to make B the subject. So you're going to have 4VB equals minus VA. So I'll divide both sides by 4. Then I'll divide both sides by 4. Okay, so this 4 will cancel out this 4. And you're going to have VB to be equal to minus VA over 4. So what I'll do is that I'll consider the downward motion to be negative and then the upward motion to be positive. It depends on you. Okay, as for the science, it depends on you. So all you have to do when writing your solution is that you explain which direction is the positive and which direction is the negative. So now we know that downward direction is negative, right? And then we know the cable at A has been pulled downward, so which means that the velocity of pulley A will be negative. So you're going to have minus 8, okay, minus 8 divided by 4. When you do this, you're going to get 2 meters per second. So this will be the velocity, okay, of the pulley B. Okay, so this will be our answer. Okay, so what will happen is that you see that the load is attached to pulley B. Okay, so it will have the same velocity as the pulley B. Okay, that's what this answer means. So now you have to find the acceleration of the load. Okay, so to find this acceleration, you have to find the acceleration of the pulley of the pulley B, and then that will be the same acceleration for the load. So let's continue. Okay, so now to find the acceleration, we are going to continue from the velocity equation we derived, which is VA plus 4VB equals 0. So when you differentiate this with respect to time, you're going to have AA plus 4AB equals 0. So you're going to make AB the subject. So you're going to have AB equals minus A sub capital A over 4. And since the cable was pulled downwards, this value here will be negated. So you're going to have minus minus 2 divided by 4. Okay, minus 2 divided by 4, and this will give us half, which will be 0.5 meters per second squared. So this will be our answer. Thank you very much for watching this video. Please make sure you like and subscribe.